here, a quarter. What's A3? Negative 1/8. Oh, it's here. So it's here. Negative 1/8. A2, I'm sorry, A3. What's A4? A4 is 1/16. Oh, even closer to 0 now. A4. Okay. 1/16. So if I look at this, so it's A1, A2, A3, A4. So it's converged to 0 because they get close and close to 0. Although the signs of the elements is minus plus minus plus, but the quantity is getting smaller and smaller. So all this, they are getting smaller and smaller all the way, converge to 0. So make a guess. So limit an and go to infinity minus 1 to the n over 2 to the n is 0. Here, and then getting closer and closer, approaching 0. Okay? So we say converge to 0. So this sequence is converge to 0. Okay? All right. So 35. Okay. So that's 37. I'm sure we can do it. Okay. And then now we should go to 8.2, section 8.2. Okay. 33. What's section 8.2? Oh, more on the sequence. So we just talk about sequence, and then now we have more on sequence. Okay, so yeah, so more on sequence, more on the recurrence things. So this really, again, we're doing the same thing. Okay, so because this is really the same thing, because this section, you see, more on sequences. So it's nothing new. And the basic idea is all what I wrote down long time ago. Not long time ago, just an hour ago. If the limit exists, it's conversion. If the limit doesn't exist, it's diversion. That's it, very simple. Okay, so let's look at some problems here. So it's 9 to 33. So exercise 8.2, number 9. So they are giving us n cubed over n to the 4 plus 1. Okay? This is sequence. Sometimes this is sequence. Okay. Sometimes they omit this. They just write. Sometimes this is the same as writing this. Okay, this is the same thing. Sometimes they write this, sometimes they write this. In the previous one, they write n from 1 to infinity. In this section, they just drop those index. But it is understandable that they start with 1 and to infinity. So the question here is what? So we forgot. The question here is that, you see here, yeah, this. Same as what I told you before. Find the limit of the following sequences and determine that the limit, determine that the limit does not exist. Okay? So we're going to determine this. Now, so how do we do a problem like this? Okay? So in other words, I'm not looking for this. So this is nth term. So what is this? That's the question. Now, you have learned, well, there are several ways you can do it. Okay, one simple way to do is I'm going to divide the numerator and denominator by the highest order of the n. Okay, so n to the fourth. N to the fourth, okay? This is one way. So this will be 1 over n. And this is 1 plus 1 over n to the fourth. Now when n go to infinity, this goes to 0, this will go to 0. So it's 0 over 1 plus 0, which is 0 over 1. 0 divided by 1 is 0. So the answer is yes, convergent. Okay, so therefore the answer is this sequence is convergent to 0. Okay. Another way of doing this is use a technique called Loftus rule. Okay, Loftus rule. I'm sure this is, I'm sure you've done it before. So another way, so one way is this. Another way is using this rule. So when I take limit n goes to infinity, n cubed over n4, n to the 4 minus plus 1, right? Both go to infinity over, this is infinity over infinity. So I can use this rule. So this is equal to limit n goes to infinity. Differentiate this. So you get 3n squared. Divide by, differentiate this, the denominator. So it's 4n cubed. Here I can cancel n squared. So this is limit n goes to infinity, 3 over 4n. 3 over 4n, well, when n goes to infinity, this is very, very large. So 3 divided by very, very large is very, very small. See? The same thing. So this sequence is convergent to 0. Okay. Any question about? So there are two ways of handling a limit like this. Let me just repeat it. Okay. There are two ways of handling the limit like this. One way is you just divide both numerator and denominator by the highest order of n, which is, in this case, is n to the 4. And then use algebra. Okay? And then when n goes to infinity, this goes to 0. This also goes to 0. So it is 0 over 1. 0 over 1 is 0. 0 divided by 1 is 0. So conversion is 0. Another one is use what we call Loftus rule. So limit of this, then you take derivative of n cubed, which is 3n squared. Derivative of n to the 4 plus 1 is 4n cubed. And you can cancel the n squared. So you get 3 over 4n. 3 over 4n, that's 0 when n approaches infinity. So this approaches 0. So this is convergent to 0. Okay? So either way is fine. I mean, just there's no which one is better than the other. It's just which one you feel comfortable. Okay. Here you have to use derivative. Here you just use division. They are the same thing. Okay. All right. So let's work on some more. I want this one. So finding limit. So how about, let's say I want to pick up some problem that looks different. Okay. So how about number 13? So this is 8.2, number 13, okay? It is 3 to the n here, 3 to the n plus 1 plus 3, okay? This sequence, I mean, the question is, what is the limit of this? Okay, all right, so I can do the following. I can use some algebra. This is same as 3n plus 1 over 3n plus 3 over 3n. Right? So this equal limit 3n, right? 3n cancel, so it's 3 first one. second one is 3 over 3 to the n. When n goes to infinity, 3 to the n go to infinity. 3 divided by 3 to the n, well, that's 0. This term go to 0. When n go to infinity, this term go to 0. So the one left is only 3 here. So that's the answer. So what? So okay. So the answer is this sequence converges to 3. Okay, because the limit exists, and the limit is so simple. I just use algebra. Okay. All right. So let me see what else we can. How about number 19? Number 19. Number 19 is 1 plus 2 over n to the n. Okay. All right. So the question I want to know is, what is this? All right. So there are. So to do this, I mean, there are several ways to do it. Normally, the one I use is simply just rewrite this into exponential form. So using the formula, I'm writing it here, okay? A to the b is always e to the b times natural log of a. Okay, the formula. So this one will be equal to limit n approaching infinity. E a to the b, right? So b natural log of 1 plus 2 over n. All right, so, and then, so I have this e, I can bring this limit into here, limit n goes to infinity, and then I'm going to use L'Hopital's rule for this one. So I'm going to rewrite this into the form, into this form. When this one is the same thing. I just divide. I mean, I just divide both numerator and denominator by n. I get this one. But this one has in the format of when n approaches 0, when n approaches infinity, right? This approaches 0. So this approaches ln1, which is 0. And when n approaches infinity, 1 over n approaches 0. So it is in the form of 0 over 0. So I can use L'Hopital's rule. Okay, L'Hopital's rule. 0 over 0. So I'm going to use L'Hopital's on this, okay? So I'm going to put on here L'Hopital's. Because it's 0 over 0. So e limit n goes to infinity. Differentiate this. Let me do it slowly. Derivative of this. And then derivative of this, of the numerator. Okay. So I'm just going to, I just want to write this slowly. N goes to infinity. This will be derivative of 1 over n, negative 1 over n squared. Derivative of this, write this, right, so 1 over 1 plus 2 over n times the derivative of this thing. Because here I have to use chain rule. Let me write this very, very slow. Okay. So this is your e limit n approach infinity. 1 over, I'm just writing a story, okay? 2 over n, and this is minus 2 over n squared, this one, and minus 1 over n squared. So I can cancel the n squared. I can cancel the negative sign as well. So this eventually becomes limit n approach infinity.